This video covers pre-calc 4.1 and trig 1.1 part 2 notes. We're going to start off today by talking about a way that we can identify our angle measurements with a lot more accuracy than just saying this is a 22 degree angle or a 32 degree angle, but we're going to get a lot more specific in terms of labeling these as degrees, minutes, and seconds. So it's just a way that we can actually make a much more accurate measurement instead of just giving it to the nearest whole degree. And so when I look at this, you're going to notice that the way that I read this is 22 degrees, 40 minutes. So one of these stands for minute, and if you see two of them next to each other, then that's seconds. So 22 degrees, 40 minutes, and 22 seconds. What I'd like you to do is I'd like you to change this into how we're used to seeing degrees, which is as a decimal. So giving something like this, 135.125 degrees. So here's how you would change minutes and seconds into a decimal form of degrees. Recognize that 1 degree is 60 minutes, 1 minute is 60 seconds, so therefore 1 degree would have to be 3,600 seconds. Think of this a lot like the minutes and seconds on a clock, 60 minutes for 1 hour, 60 seconds in 1 minute, and then 3,600 seconds in 1 hour. So if you're going to break this down, here's what you do. You would take the degrees, because you want to keep your answer in degrees, add to that the minutes divided by 60. Since there are 60 minutes for 1 degree, I'd have to take 40 out of 60. And then since there are, if I'm trying to change seconds into degrees, there are 3,600 seconds, so I'd take 22 and divide by 3,600. And then I can just type that in the calculator and get it to be approximately 22.67 degrees. So again, I'm writing this as a degree measurement in terms of decimals instead of saying specific minutes and seconds. Now, if I'm given the degree measure in terms of a decimal, but I want you to tell me how many minutes and seconds that is, here's how you would do that. You are going to separate the partial from the whole. So in this case, the partial would be the 0.125. So the 0.125 is a part of a degree. So to change it into minutes, you times it by 60. So what I'd come up with is 135. When I take 0.125 and times it by 60, I get 7.5. And again, what I'm going to do is I'm going to separate the part from the whole again. So I've got 135, that's a whole, 7 is a whole, the part is the 0.5. So take 0.5 and times it by 60 again. Because now I'm trying to change half of a minute into degrees. I said that backwards. I'm trying to change decimal degrees into seconds. That's what I'm trying to change this part to. So when I multiply this out, I end up with 30. So I'd have 135, 7, and 30. And now I can just go through and put my symbols in there. This is 135 degrees. This is minutes, and this would be seconds. So each time when I did this, what I ended up doing was taking the partial, the decimal in other words, the 0.125 times it by 60. Let's take off the whole part of that. So in this next case, the whole part was 7. Take the whole part off, put the decimal part off to the side, times that by 60. And I keep doing that until I don't have any more decimals associated with that. So I could say that 135 degrees, 7 minutes, 30 seconds is approximately 135.125 degrees. This next example is going to ask you to change from degrees to radians or radians to degrees. So let's talk about the relationship that there is between degrees and radians. We've kind of addressed this in part 1 of the video, but I said that 180 degrees is the same as pi radians. We can use that relationship to help us change any degrees into radians or any radian measurement into an angle in terms of degrees. Here's how you would use that. You'd use this relationship, theta over 180 equals theta over pi. So if I'm going to try to change 30 degrees into radians, what I'd want to do is plug into here 30 degrees, since that's what I'm given, over 180 degrees, and that should equal theta radians over pi. So I'm going to cross multiply here. I'd get 30 pi equals 180 degrees times theta. I'd solve for theta, and I'd end up with, if I divide this out, 30 goes into here 6 times, so it would be pi over 6. Notice that I'm not putting it into the calculator, because if I put it in the calculator, I don't get a pi. So I can say that 30 degrees is the same as pi over 6 radians. Another way that you could have done this, instead of having to write a proportion and solve it, is if you want to change from degrees to radians, you can times then just by the relationship 100 or pi over 180. So let's do that also, so you can see I'm going to get the same answer. If I take 30 degrees and I times it by pi over 180, I end up with 30 pi over 180. Again, that's what we had here. And then if I reduce this fraction, it becomes pi over 6. So a lot of students find that using this relationship to change from degrees to radians, so I'll just put d to r, so you know that's degrees to radians, works out pretty well. So let's do that with this example then. If I have 220 degrees and I want to change it to radians, times by pi over 180. So you end up with the fraction 220 pi over 180. Reduce that fraction, you'd end up with 11 pi over 9. If you are going to be putting this into the calculator, don't put the pi in the calculator, just type in 220 divided by 180, change it to a fraction, in this case improper fraction, and then tag the pi back in the numerator with it. And so you'd get 11 pi over 9. So again, you can use this relationship, or you can use a much easier one that just says multiply by pi over 180. Let's work the other way now. Let's say that I wanted you to go from radians to degrees. So if I want you to go from radians to degrees, you would multiply by 180 over pi. Okay, so again, the shortcut, if I'm trying to change from radians to degrees, would be to be timesing by 180 over pi. So let's do that. If I'm given the fraction 3/2 pi, I'm going to write it like this. I'm going to times by 180 over pi, which will make my pi's cancel out. And then I can look at this and say 2 goes into here 90 times, and then 3 times 90 is 270 degrees. So I can get this to be 270 degrees. Now, notice that for this problem, I asked you to change a radian that was a fractional measurement with a pi. This time I'm asking you to change just a whole number. There's no pi with that. So when there's the no pi with it, you can't do the multiply by 180 over pi. So you can't do the shortcut here. So you have to actually use this ratio here. So this time when I do it, I'm trying to find theta in degrees. So I put theta over 180 equals, and now I'm trying to change 2 radians into degrees. So for this problem, I would cross multiply and get theta pi equals 360. And now when I divide by pi, I end up getting 114.6 degrees. So you can only do this shortcut if you're given a fractional radian in terms of pi. If you're given a decimal form, 2 is a decimal, 2.0 of radians, then you have to actually use the formula. So I have to use that formula. Alright, the next concept we're going to talk about is finding the arc length. And basically what the arc length is, if I asked you to find the arc length of this circle, I'm asking you to find, you'll notice what my arrow is showing, I'm asking you to find this distance, in other words, part of the circumference. So there's a formula that we have. That formula that we have is right here, that theta is equal to the arc length divided by the radius. So if I want you to find the arc length, which stands for the s, you're going to plug into your formula, theta, which is 240 degrees. Actually, I take that back. Part of the formula says that you have to have theta measured in radians. So if I've got 240 degrees, I have to change it to radians first. So we have to do what we just did in the previous example, times it by pi over 180. So I'd get 240 pi over 180, which will reduce down to 4 pi over 3. Okay, so plugging into this formula then, theta, which is 4 pi over 3, equals my arc length s, which is what I'm trying to find, over my radius r, which is 4. So there's a couple ways I can solve this. Since I'm trying to find s, I can just multiply by 4, or I can cross multiply this proportion. I think the easiest way is to just multiply by 4 to get rid of that. So this becomes 16 pi over 3 equals s. Probably going to want to give it as a decimal. If I asked you to give it as an exact value, that would be the answer. If you're going to give it as a decimal, you just type in the calculator 16 pi, get an answer, divide it by 3, and I get 16.8 if I round it. And this would have to be, I should put some units with it, inches would be my arc length. So this distance would be 16.8 inches. The number one mistake that students will make when they use this formula is they will not change theta to radians. You have to first change your degree measurement into radians, otherwise this formula does not work out. Okay, the last topic for this section of notes is finding the area of a sector. So that's saying finding the portion of the area of a circle. So not the entire area, but just a portion of it. So here's the formula. Area equals half of the radius squared times theta. Again, theta has to be in radians. So if we look at our theta, it's not. So let's change it to radians by multiplying by pi over 180. So 45 pi over 180, if you reduce this fraction, 45 over 180 is 1/4. So you'd get pi over 4. That's what we want to use for theta. So now plugging into my formula, take half the radius, it says my radius is 12 millimeters, so r is 12, squared times pi over 4. Again, if I asked you to give an exact value answer, you would type in the calculator half times 12 squared and then you would times it by, there's an imaginary 1 here, put that in a different color, so this would become 1/4, so then you times that by 1/4 and you'd get 18, and then you just stick the pi back with it. So that would be the exact value answer. If I asked you to, and it would be millimeters squared, if I wanted you to give me a rounded answer is much easier. You just type everything in. You type the pi in the calculator as well. And so doing this, I'd end up getting an answer as 56.55 millimeters squared. So again, just pay attention to whether I ask you to give an exact value or a rounded answer for the area here. Rounded is pretty easy. Type everything in. Exact value is pretty easy too. You type everything into your calculator except for the pi, and then you just tack the pi onto the end of it. But again, to use this formula, you can't use the theta in degrees. It has to be in radians, otherwise the relationship doesn't work out. And that's the number one mistake that I see students do, is they keep it in as 45 instead of changing it to radians.